Mark your back.
And I see a question here too about what can you use to drop out tartrates. You can't, I guess if you can't get a white wine cold enough. Michael, are you there? Maybe Michael took a break too.
I think he did.
Yeah. So
no, I'm here. I was on mute. I forgot.
Oh, hey, Michael, do you want to talk about this? Tartrates and Claristar?
Insofar as, let's see, what's the question? What's the question?
Removing tartrates. Talking about removing tartrates if you can't get a wine cold enough to cold stabilize.
Okay, so yeah, if you can't cold stabilize it, you're not removing the tartrates with Claristar.
Yeah.
What you are doing is you're adding a manoprotein that actually changes the surface of the crystal or the crystals so that it cannot grow. And there's another, both Claristar, which is a natural manoprotein, or there's also a man-made polysaccharide called CMC. They both accomplish the same things. Of the two, I prefer the Claristar just because I try to minimize sort of the so-called chemical additions to my wine. I'm not a big fan of CMC just because, well, I deal with a lot with sparkling wine, and there have been a couple of instances where people have tried to save time and money by using CMC on a sparkling wine, and it was very high in tartrates and overwhelmed the CMC, and the finished sparkling wine looked like it had translucent grains of rice floating through it. The Claristar, you use it on basically on whites. You should not use it on rosé or reds because it can destabilize the color. I would say, I know that, well, remember Stefan, who came from, I think it was, came from Appalachia State, didn't he?
Originally from Germany.
Yeah, I knew that. Yeah, but
yeah, App State.
Yeah, he was saying that in his research, he feels that what you're doing with the manoproteins and with CMC is you're delaying the falling out of the crystals. It's not a limitless thing. So it's meant to be used for wines that are going to be consumed relatively young, perhaps within a year after production.
And I'll also add that the Claristar, that it's only for potassium tartrates and not calcium tartrates, which I feel like up and down the East Coast, I've seen a lot of wines with a lot of calcium tartrates, so it won't help with those.
Is that because of high calcium levels, or it's because of treatments?
I don't know very many people that are adding calcium carbonate to their wines here because we would like the pH to stay low. So I'm guessing it must be vineyard specific. So
okay,
but just something to keep in mind as well. Anyways, Mark, I think we're ready for you now.
All right. Well, I hope my power company is ready too. So all right. Sorry about that. I hope we can save the recording. Patty, did it record through when I was? Did it stop recording?
No, I think it continued recording.
Okay. Good. All right. So we're gonna go over this very quick. I feel we talked about it a couple of times already. I will share my screen with you guys. There you go. And so this year, harvest for most, but not all the places, but most places will be pretty difficult because we had a lot of frost damage this year. Late year this year, last frost I believe was mid of May, May 14th, I believe it was. So we see a lot of uneven ripening and a lot of dormant buds breaking and a very delayed fruit ripening as well. So we're going to talk about this a little bit today and how we can deal with that in the future as well. So first of all, what we see in the vineyard is we see a lot of vines which don't have any fruit on them, like this guy here, for example. We see a lot of that in several blocks, and that needs to be counted later as like a non-existing vine, basically. So some, if you do your fruit crop estimates. And then we see a lot of uneven ripening, like we see here, where we have clusters which went almost through horizon as well, and others which are still in the first phase. And then we also have very uneven distribution of clusters here. For example, this is like a good example where we have some areas where we do have good growth, and then other areas where we do not have any clusters as well because of the frost damage. So again, we see a very different picture than we usually would see in the vineyard. And then, of course, we have also vines which weren't affected or weren't affected that much. So we have a very variable situation in vineyards. And I wrap my brain a little bit around this, since this is my first late frost in North Carolina with grapes. What the reasons are and how can we deal with this in the future. So, and I made a little bit of math. I looked back because I arrived here 2017, and I looked back in weather data in the last 15 years. And what you see here are on the left-hand side, it's April and May. So the times when we do have usually frosts is usually in April. And you can see here over the last 15 years, we always had days below 41 degrees Fahrenheit, usually. So you can see frost even on days where it's higher than freezing, because frost is a radiation problem. If you do not have cloud cover and you have a clear night, you will see frost even if the air temperature is above freezing. So I counted basically all days which were below 40, because that's usually when I start getting concerned about frost events. And it's very consistent over the last 15 years. In April, at least, we always had frost events, several days where we had temperatures below 41, which were potential frost days. I didn't look into actual frost days because I did that yesterday night. And that is only for one location in North Carolina as well. The same in May, and that relates to something which Tony Wolf said a couple of years ago, that we do have every once in a while days which are potential frost days, even in May, so late in the season in our area in the southeast. So as you can see here, we had always potential frost days in 2005, then 2013 one, and then 2020. 1 or 2 days, depends on the location, where we had potential frost days in North Carolina. So that seems to be a reoccurring thing in North Carolina, which are in the southeast, which we're going to have to deal with on a frequent basis if we talk about late frost events during the time where we shouldn't have any frost anymore. A new thing which we also have to deal with in North Carolina a little bit more are heavy rain events. So I counted all days here, again for this one location, where we had rain events which gave us more than 0.5 inches per day of rain. A lot of them were much higher than that. A lot of them were close to 1 inch or 0.8 inches per day. And that is something which obviously in that particular location did not happen that much between 2005 and 2013. Then started, we see that more frequent, actually every year since 2014, both months really. And then this year we had a lot of rain this year, which also contributed to fruit set and other things and rods and spray programs and etc., which we're gonna have to deploy in our vineyards. So that is a new thing, and we also have to wrap our brain around how to deal with that. But again, frost events late frost events seem to be reoccurring every 10 years-ish in the southeast, and then now it's coupled with some heavy rain events as well, which we get frequent over those 2 months. So the main problems is that we have with some, especially with the hybrids, we have primary and secondary clusters, and we have a lot of dormant clusters breaking, dormant buds breaking. We have uneven ripening in some of the vineyards, and then also uneven cluster and vine distribution, and also the estimated cluster weights might be a little bit off this year. So the big questions for me this year was what do we harvest at all? How do we assess the representative number of clusters per vine for one block, and how will the clusters we harvest this year have similar weights to the last year? And just to remind everybody, this is how it works. Usually we have like 3 phases in your berry development, and often, or usually the cluster, your crop estimates are around stage 2 of your berry development, which is pretty much now. And so I want to talk about 2 crop estimate methods: harvest cluster weight methods and lag phase methods. And I know Sarah from Circumventus covered this at a different talk a couple of months ago. So I'm just going to go over this quick. For both, you need the number of bearing and non-bearing vines per acre, which this year is going to be different because usually you only count your dead vines, but this year you're going to have to really go into the weeds and see which vines are you going to harvest, which blocks are you going to harvest, which blocks are you not going to harvest. And you also need the number of clusters per vine, which also are very different this year than to a usual year because there's a lot of variation in it. And then the difference is that lag phase relies on this year's season cluster weights, as you know, and the HCW relies on the weights from the last seasons. So it relies on a good record keeping, basically. Harvest cluster weights method is the number of bearing vines times the number of clusters per vine, and then times your multi-year cluster weight average in pounds divided by 2,000. That gives you tons per acre. Usually you do it for each cluster, or usually you have your method down. This year, I think uniformity of age and vine size is very important. Also, look at the uniformity of damage or loss you have in your vineyard. So that is extremely important as well for this year. If ripening is uneven, you have to make basically a decision. You have to talk to your winemaker, and if you not have it already, or if you're the winemaker itself, you can make that decision if you want to harvest that block or not harvest that block. And I give you some examples in a second. Only count the clusters that you also will harvest. So you have to make a decision on which clusters you're going to harvest right now. And then if ripening is delayed, we think that harvest can be delayed. Some of the late cut-withs might, because we'll be 2 weeks behind. So some of the late cut-withs come in like late October this year. And then also talk about wine style decisions with your winemaker. I think we covered a lot of that already. If you have wines like this, obviously you're not going to harvest anything there because they don't have anything. So that's a no-brainer. That should be counted as a loss this year. You have situations like this where you have only like 2 clusters on the whole vine, and the question, and you know, not really big clusters as well because we had a lot of rain too. So the question is really, do you want to harvest this or not? I would almost say no, but that really depends on you. Then you have places where you have very low cluster counts. Again, you have to make the decision if you want to count it as a bearing wine or a non-bearing wine, and if you want to harvest those clusters or not. And that decision needs to be made over the whole block if it's worth your time, your effort, and the work, especially since we had a really good year last year, and we might be able to take some hits. And then only count the clusters which you want to harvest. If you have uneven ripening here, again, you have to make the decision which ones you want to harvest and which ones you don't want to harvest. and then make an overall assessment in your blocks. So really walk the vineyard and make an overall assessment so that you can come up at least with a percentage of how many wines are affected and how many wines you're gonna harvest and how many wines you're not gonna harvest. So number of wines usually are calculated by row width and wine spacing. Again, count all the wines that are not being harvested or that are not bearing this year. It's going to be a lot more than usually. And of course, count all the dead and diseased wines. And then, as an example, let's say we have 726 wines, so we have a 6 feet spacing and 10 feet row width, and we have 5% that are dead and 25% in that particular vineyard which are not bearing. So we're talking about 508 wines which are actually going to be harvested this season. I want to give you a real-world example of one of our research plots which we have. That's a Merlot plot, and we had got hit pretty bad by frost there. We have about 75% crop loss estimated by the grower, and it's a VSP trained system. Because it's a research block, we really pruned it down to 2 buds per spur. We thinned it to 12 shoots per wine, so we had it very standardized, much more than you would in a normal vineyard under normal management conditions, because we wanted to get our yields correct. And this is what we have in terms of clusters in this particular block. And this is not the whole block, this is a part of the block, but we did cluster counts there 2 weeks ago. And this is what we have. And you can see it's all over the board. So we have wines with 2 clusters per wine, all the way up to wines with 16 clusters per wine, which was, I think, the highest in our block. Or maybe we got something higher. 17, we have 117. So that is what we got there. A huge variation, and that is just an example of how it might look in your vineyard. And so if we do clusters per count, and we do the multi-year average in that particular vineyard for that particular cultivar, which is about 29 clusters per wine, the grower was pretty right with his estimate. We had about 73% crop loss if we count only clusters. So now, but how do we assess it in a larger vineyard? So I want to give you like a small little example with this particular part. So if we do 20%, if we assess 20% of the wines in that vineyard, but we go for those with higher cluster numbers, we end up with a high cluster number. We end up with 10 clusters per wine if we do even 20% of the vineyard. The same if we do select 20% of the vineyard, but we mostly select wines with low cluster numbers, we get a too low number, which in this case would be 5 clusters per wine. So what we really have to do is go through the field and select a mixed bags of wines which have higher numbers and lower numbers of clusters, so that we can come up with a more or less estimate of what is actually really happening in the vineyard, which in this case is 7.6 clusters of wines in this particular case. So now we can reduce that, because 20% is a lot, and usually it's about 4 to 5% what people do. So I reduce it to 5%. And if we select the right areas, we can come up with 8.25 clusters per wine here in this case, which gets us close to what really is happening. But if we select the wrong places, we can easily be off this year a lot if we only do 5%. So our recommendations is look at every block, because all the blocks can be very different, and create meaningful blocks that reflect a similar pattern at the majority of the wines. That is really important. Even if it's the same cultivar, you're going to have to go through 2 times, you probably have to do that. And then in those blocks, you can assess the number of clusters by assessing equally the whole bandwidth of cluster bearing. And we recommend to do that more than the usually 4 to 5% you would do, because you have such a huge variation. If you got hit by frost very well, there are some vineyards which are not got hit by frost that much, so they're going to be, they just do their normal procedure. But if you got hit by frost that much, I would recommend to do more than 4 to 5% per block of in the vineyard. Cluster weights, again with the HCV, you would go with a good record keeping, so you would go with the average rate of the last couple of years. In our case, the vineyard has a very good record keeping and for that particular cultivar, not for that particular block, because you don't have those records, but you have the records for that particular cultivar. It was about 0.4 pounds per cluster, which is pretty large for Merlot, but it is what it is. And we had 508 bearing wines in our example. We had 8 clusters per wine as we counted, and we have 0.5 pounds per cluster. So now we can do the math. And we come up, if we do 508 wines times 8 clusters per wine, 0.4 pounds, we come up with an estimate of 0.81 tons per acre, which seems to be pretty accurate to me in that particular vineyard. So that would be our estimated yield there. Again, yield estimates are never completely correct, so you always have to count like 0.15, 0.2% more or less. So if we look at what we have on average with 29 clusters and 690 wines, we would usually shoot for about 4 tons per acre, which now we have about 80% loss in that particular vineyard. So that is one method. And then the second method is the lag phase method, which maybe some of you use. Again, the lag phase is determined as the period in which there is little growth, mass or volume of a berry. It's usually determines phase 1 and phase 2 of your berry growth, which is phase 1 is the phase of rapid growth after anthesis. So from basically pollination all the way to your phase 2, and then your second phase is the fruit maturation, which then leads to your higher sugar levels. So the lag phase is from cultivar to cultivar very different, and determination of lag phase is, at least in my opinion, not trivial. It depends a lot on your experience, and you have to treat every cultivar a little bit different, because some cultivars have like very short lag phases, others have very longer lag phases, and you need to sample your fruit before the maturation starts, and you need to do that frequently. And if you're at the place where you say, you know what, we are in our lag phase and we're going to do our estimates now, then you need a lot of labor also to like get the fruit and a good amount of samples and to do your crop estimates. So having said that, in our example, we were at 0.16 pounds, which means we have 0.18 pounds, sorry about that, and that which means we had 0.36 pounds of estimated crop, because what you would usually do, you would say in the lag phase, your crop is 50% of what it is at the end. So that's again an estimate that gives us 0.73 tons per acre if we do that, if we do the math here. So which means in the HCW method, we got 0.81 tons to the acre. With the lag phase method, we got 0.73 tons to the acre. There are positive and negative things about both of those methods. HCW depends a lot on your history of accurate yield data. And again, that might be a little different this year. And then your lag phase depends a lot on your experience and your labor availability as well, because you need to get a good amount of berries in to do that. And then also berries don't ripen on the same cluster at the same time. So you really have to take that into account as well. So again, it takes a lot of experience to do lag phase. As a conclusion, divide your vineyard into medium fruit blocks, subtract the number of wines that won't be harvested from your total wine counts. That's really important. And increase the number of wines that you will count for clusters. So don't go with your 4 or 5%. I would do more than that this year. And yeah, that's it from my side. I really jumped through this like really quick. So, but if you have questions, just let me know. All right. And David, it's your turn.
All right, let me get set up here. 1 second. All right. So today we're going to talk a bit on my side about harvest lab preparation. Hopefully a lot of you guys are doing your own measurements. If you're not doing your own measurements, then you're probably sending those out, which is perfectly fine. Just a point here in that many times when we're in the winery, we need to get data back quite quickly in order to make processing decisions. And so I would recommend, just as a basic level of winery lab technology, to be able to measure Brix and pH in your wine lab. If you can't measure that, then you're not going to really be able to make the decisions quick enough to adjust your acid and your sugar, which is going to play a major part in the final wine. So that's what I would initially say and recommend. TA, yes, is definitely important, but probably not as important as pH and Brix, though definitely still important. So you know who I am, David Bauer. I've been at Surrey Community College for almost 9 years now. I also teach for VESTA, the Viticulture, Enology, Science and Technology Alliance, which is based out of Missouri State University. It's an online grant consortium of community colleges. And I also teach for Sonoma State University in their wine business program. And I do have my own consulting business that I work with a number of different people on really just educating them about how to make better wine. Not necessarily making wine for them, but making better wine and kind of getting them on that right track. So today, we're going to talk about lab preparation and getting prepared for harvest. We're going to talk about warming up the equipment. I know what a lot of people do is that they will use their pH probes and their equipment only during harvest. And I would say, I'm going to get more into this, that is a bad practice. We're going to talk about major tests that you should be performing. Talking about Brix, pH, TA, and Megan covered YAN. YAN is a very important measurement. You need to have an understanding of where your starting YAN is if you're going to be making your way down into the rabbit hole of determining YAN additions and maybe looking at more complex winemaking practices and identifying what yeast strain you want to use, and thinking about if you want to make esters, or if you want to create these enzymes that release thiols, or if you want to try and to prevent loss of terpenes. All of these things are more advanced and definitely something that I would recommend that you think about, but are, definitely, like I said, advanced topics. How to perform chaptalization. So chaptalization we'll talk about, how to perform acid adjustments, and keep in mind pH and also potassium content. And then I put down here at the bottom and I guess I'll touch on some of these things, but these are not tools that every single winery uses. There are some wineries that do use these types of tools, but again, getting more on the advanced side, looking at the conductivity probe. Using a conductivity probe to evaluate press fractions is something that we started at the college, which is interesting and definitely makes a difference in terms of evaluating press fractions in lots for blending and for pH. And then using a nephrometer, which gives you a NTU reading, which we talked about that at the beginning, using NTUs to determine how many solids you have. A densitometer. We are going to start using a densitometer instead of Brix this year. So densitometer is definitely more accurate in terms of looking at sugar content. Centrifuge, maybe you use a centrifuge to pre-clarify your samples, your juice samples before you go into the lab. That would be my recommendation. And then if you're using an automatic or a semi-automatic titrator for your TA, some of you do have those little Hanna automatic titrators, ensuring that all of the parts are working. And I would recommend replacing the tubing on all of those once a year. maybe using a water bath or graduated cylinders and beakers, of course, and ensuring that you have those tools in place before you get into the harvest. And, you know, you can purchase the graduated cylinders and the beakers and to refresh your glassware. I just put in a large order for a glassware refresh for the college, and you can grab all that from Carolina Wine Supply if you'd like. So getting your lab ready, I'm going to first just briefly talk about PPE standards now. I would say in general in the laboratory, always using gloves whenever you're working around any sort of reagents. And I would say also eyewear. So definitely wear goggles. You can get yourself a cool pair so that, you know, those black ones that are kind of outlined, that can be the cool winemaker with those cool glasses. It's always good also in the winery to have some eyewear as well, because, you know, juice and acid and things and sanitizing chemicals and those types of things can all splash up in your eyes, you know. So I would say definitely as a basic standard before COVID-19 that you should have those things. But now I am just going to briefly talk about FSMA and FDA requirements. So under the Food Safety Modernization Act, so under FSMA, the FDA requires good manufacturing practices. Good manufacturing practices apply to everyone that produces food, right? And so you are required by law to have good manufacturing practices. And what those good manufacturing practices do is look at a couple of different parts. There's safety of water, there's condition and cleanliness of food contact surfaces, there's prevention of cross-contamination, there's maintenance of hand washing, hand sanitizing, and toilet facilities, there's protection of from adulterants in food and to the human element, there's labeling, storing, and proper use of toxic compounds, there's employee health conditions, and there's exclusion of pests. So you have to be aware and you have to train your employees on each one of these 8 subparts. And you have to keep the title of the training, the date of the training, what your employees were trained on, and the supervisor's signature. So if you were ever audited by the FDA and the FDA has assessed fines for violation of good manufacturing practices. How is that applied in North Carolina? That's applied through your local agricultural agency, and there has been money that has been put aside now to have people come out and just randomly inspect and make sure that you have this training. Under the GMPs, the one that is I'm just briefly going to talk about for just 1 minute is in the lab, we're looking at labeling, storing, and proper use of toxic compounds. Everything that you mix up or everything that you have has to have a label and an open date. So all of that has to be stored and labeled and have that open date on there. And then the other piece is the employee health condition. So what that means is that in the winery and in the lab, right now in response to COVID-19, there has to be mask worn. There also has to be eye protection that's worn at all times, and there has to be gloves that are worn at all times. It doesn't matter if you are in the winery or if you're in the lab. All of those things have to occur no matter what. So if the FDA came in and you weren't doing those things, that would be a big problem. We're not able to social distance in the winery typically because we do have a lot of people that are running around, especially during harvest. What we are more likely doing is something called physical distancing. Physical distancing is a little bit different. That's being around people, but keeping physical distance. So there is no substitution for 6 feet of distance from every single person that you're working from. But if you're on a sorting table, that may not occur. Now, just be aware that if you are close to people, you increase your risk of contracting the virus. It does not matter if you have a mask on or not. At the maximum of 15 minutes, what the research has shown is that you effectively lose mask prevention of virus by about 50% if you are that close, due to buildup of particles, micro droplets that get on your clothing and get on your mask and such. So creating a physical barrier would be my suggestion. But as in terms of GMPs and what the FDA requires, you need to wear a mask gloves, eye protection within the winery at all times. Okay. I would check out and make sure if you have the proper cleaners and sanitizers, and of course paper towels. I would also make sure that you maintain your hand washing station. As part of GMPs, you need to be washing your hands before you put your gloves on and before you put your mask on, after you take your mask off, and after you take your gloves off, and hand washing should occur at regular intervals throughout the day. Typically what I am teaching right now is between 3 and 4 hand washings per day. That does not mean, it does not matter if you have gloves on or not. Typically what a lot of people do is they consider their hands sterile if they have gloves on. That is not true. You're supposed to wash your hands before you put your gloves on, and wash your hands when you take your gloves off. So stock up on all sorts of soap. Okay.
David, can I ask a question quick?
Sure.
So do you guys have like any plans in place to like separate work processes so that not that many people are congregated on one spot? Or is that not possible?
I would say if you can come in shifts, or if you could, if you are having a lot of people that are around, keeping a smaller group is just a better practice. Or if you have a larger group, then to separate the workout into shifts, have a morning shift, have a break in the middle that you meet with the manager of the morning and the night shift, and then have the night shift. It may not be, you may not be able to do that if you have just like a very small group that you're working with, but separating out jobs in the best way possible so that you can maintain that physical distance is definitely more preferable and will reduce your risk. Does that answer your question?
Yeah, no, it's great. Thank you.
Yeah. Best thing you can do is to buy yourself a big jug of ethanol and dilute it down to 70%. The virus, there's conflicting research, but the majority of what you see is that it's not surviving on surfaces for like a very long period of time. You know, main method of contraction is micro droplets getting into your throat, or you touching your mask, and then or, of course, touching anywhere on your body that somebody spit on you, because whenever we talk, you're getting spit on. Sorry about her. The mailman must be here. Hold on one second. So getting, spit on you, and then you're touching your mask, and then, of course, you touch your face. What I would also recommend, just as a point of learning about how to use a mask, is you only touch the back, you only touch the loops, never touch the front of the mask. People, I see them all the time adjusting, things of that nature, only want to touch the loops, okay? All right, so want to make sure you get yourself, some sort of sanitizer. You want to sanitize lab benches. You should have ethanol around, or you can use 3% hydrogen peroxide, but that is not something that's recommended from the FDA to kill the virus. So if you go, there's to the FDA, the EPA website, there is a list. It's called N-rated sanitizers and cleaners, but the sanitizer list is what you would like to look at. That N-rated list is all the things that are recommended to kill the virus, but we have to be very careful because the EPA recommends sanitizers that have chlorine in it, and we can't use chlorine in the winery. So shouldn't be using chlorine in the winery or in the tasting room for risk of TCA. So all of that stuff is going to make harvest more complex this year. And of course, working in the lab, many times we're in much closer quarters. So maybe one person works on lab work while one person's outside, racking things around or doing some sort of winery activity. You may want to make sure that you work in pairs, but again, keep physical distance. I would take an inventory of all your lab chemicals. Think about what you're going to perform and what you're going to run in the lab. So if you're going to send out samples, just be aware that there's going to be some turnaround time there, but plan for that. You might have to go through a settling period on your juice, and so that's enough time for you if you can overnight your sample to a lab. Of course, the cost there is expensive. You may want to overnight that sample to the lab, and of course, you got that 24-hour period of settling. Then you can send that out. You should get your results back by the time that you need them to add supplemental nitrogen for your fermentation. But just be aware that there probably will be some increased wait times due to COVID, most likely. I would say make sure you stock up on everything. And I just put a little list here because let's say we're just doing PHTA and bricks. The biggest thing that we want to have enough of is pH buffers and storage solution. You never want your electrode to dry out. You never want it to be exposed to oxygen for a long period of time. And that you also want to make sure that your pH buffers are fresh. And that your NaOH is fresh if you're doing any sort of titration with that strong base. So how long do buffers last? That's like a huge question that I get all the time. For buffers from 3 to 7, they last open for about 4 to 6 weeks. My recommendation would be to replace every month. So think about how many pH measurements you are doing. If you're doing pH measurements to determine pH increases during pressing, then you're probably going to use a lot more buffer. 10 buffers, only 1 to 2 weeks. So if you're using a 3-point calibration, so let's say you're 3, 7, and 10, or 4, 7, and 10, the 10 buffer is only going to last 1 to 2 weeks. pH storage solution, that needs to be changed out. So just you need to have a new beaker with new storage solution every time you perform a measurement. So you need to go through a good amount of buffer, of storage solution. And then the cleaner, I would recommend cleaning your electrode always. It's very, very, very important on a consistent basis. Maybe what Hannah would recommend is probably once a month to clean that of wine deposits. The glass is semi-permeable in the actual pH bulb. So, wine deposits can get stuck and stuff in there. And of course, on the junction where you do have some leakage of the internal internal solution, you can have all sorts of wine deposits that get gunked up. You don't want to clean it too often, but you definitely want to make sure you keep it clean. If you find that you're getting weird pH readings or that you're getting pH drifting, where the pH probe is maybe moving around in terms of a data point and it's drifting up and then it's drifting back down, that means that you probably got a little bit of an issue in terms of cleaning, or it wasn't held correctly, maybe maintained correctly. And so you'll probably need to replace the probe, but let's try and clean it first and recalibrate before we replace the probe and spend that money. For NaOH, if you're doing any sort of TA, you're going to need some NaOH. You want to make sure that it's at the proper concentration, i.e. the proper molarity. My suggestion would be to buy the granular NaOH and then just use a volumetric flask and mix up your NaOH whenever you're needing to run a TA. That's going to give you the freshest NaOH, and it's going to give you the best result. If you don't want to do that, you can buy it pre-made, but again, you need to replace that most likely every 3 weeks. So don't use any old NaOH that, again, is not going to give you the most accurate reading. These are all very best practices. I know a lot of people don't do this, but this is what I would recommend. And then DI water, do you have enough DI water? You need to be using DI water for your rinsing. You need to be using DI water for your TAs. So for your calibration of your refractometer. So you want to make sure that you have enough DI water on site. And if you are producing it, is your equipment working properly? Or if you're purchasing it, make sure that you have enough. You may want to stock up. You want to definitely maintain those pieces of equipment, make sure that they're working properly before harvest. And I'm just going to talk a bit about maintenance in a little bit. And then, I talked about sending out samples. If you are sending them to a lab, make sure that you have enough storage tubes, sample tubes, and processing bags, things, envelopes, things of that nature to send those samples out. You don't want to be in a position, it's 1 o'clock in the morning, you just processed for 12 hours and you need to get the sample out early in the morning. You don't have the bags. Now you got to wait 24 hours or pull something together, at the last minute. So make sure that you have enough of those things. So, maybe create a checklist. might be nice for you to do. So in terms of pH, we want to make sure that we're calibrating on a regular basis, and that we record the calibration. And there are a couple of different values within the calibration step that are going to help you understand if you have an accurate pH reading. So I will say that a lot of people just do a 2-point calibration, and that is sufficient. That is what pH has been based on for a long period of time. If you want to increase the accuracy of your pH measurement, you can use a 3-point calibration. It's very difficult to get 3 buffer. It is also more expensive to get a 3 buffer. But it is helpful because most of the pHs that we see in wine are between 2.8 and 4.2. And so that's very helpful because what the buffers do is create data points so that the pH probe can analyze the sample pH. So what I would say is, if you are, just very basic, what you can get nice 4 and 7, replace that every 6 to 8 weeks. Make sure that you have enough. Okay, they can come from Carolina Wine Supply, that's fine. Ensure that those buffers are accurate. Ensure, with your probe, when you put your probe in, make sure that they are 4 and that they are 7. I've had problems getting buffers that were inconsistent. Maybe they were too high, maybe they are too low. So buffers are definitely a source of constant turmoil. And making sure that you have great buffers is part of doing the pH measurement. You just have to make sure that you work with those buffers correctly and that they're fresh. So when you do calibrate, you want to definitely do that 2-point calibration. The 3-point is maybe a little bit better, though it can cause you some stress if those buffers are a little out of whack. What the calibration does is it generates a slope and an offset value. And the slope is something that you hold internally. So for your winery, you would establish what your agreed upon slope is. So slope looks basically at, sorry about the train, slope looks specifically at how accurate your reading is. And in terms of looking at the internal pH scale that the meter holds. So if you've got a percentage slope of like 80%, typically that would not be a value that we would accept in terms of an accurate pH reading. What many people will say, all of the different pH manufacturers, is a slope between 85 and 105%. So you want to have your slope between there. So at the Surrey Winery, we typically like to be around a 90 to a 95% range. This is specifically referring to the accuracy of your pH reading, and of course the condition of the buffers. And then in addition to that, we also look at the millivolt offset. So you should be plus or minus 30 millivolts. That's the recommendation for that measurement as well. So you should look at both the slope and the offset. Those should be, pH probes should be calibrated at least once a week. You can calibrate them before the measurement as well, or you can just calibrate once a week, record the calibration data, and then go back to it the following week and calibrate again and record that data. I like to just keep it on a pad, or I just stick it right on the pH probe. That we've calibrated, we're good to go, and we are within the benchmark ranges for our winery. I think most of you know what pH is. I'm not going to go through that. This is just a reminder when I do share the slides. But in terms of evaluating, you want to definitely consult the operator's manual for standardization. You definitely want to look at the operator's manual for the type of probe that you have. You should really have a conical or a spherical probe. So, when you're thinking about the probe, it's got a round bulb on the bottom. There's a junction point right above that round bulb. That's very important because part of this internal solution will leak out and create what is your pH reading. based off of what the internal solution is, and then also looking at the calibration standard that you establish. You want to make sure that your pH probe is under the surface of the sample. You want to make sure it's under the junction point. You also don't want to you want to make sure that it is not touching the bottom and it's not touching your stir bar. Typically, we are going to stir the wine up to mix up the solids, or the juice up to mix up the solids. That's going to give us a more accurate data point. It also might cause the pH reading to drift a little bit. If it's drifting a little bit, it should stop. It should stop. If it doesn't stop, then we need to go back to square one and try and clean or look at, our probes. So I put in some troubleshooting here in just two forms. I got a graphical form, and then I've got some things to look at here for when I share the slides. But ask yourself when you're in the lab about pH, how old is the probe? The probe should be replaced every year to 18 months, regardless of condition. Has the probe been stored correctly? Probes should be stored in a storage solution. You can't use DI water to store it, and that's because, like I said, the storage solution has a very specific millivolt level that is known to the meter that needs that to function. Have I allowed the probe to dry out? I know some of you were out during the COVID outbreak, and so maybe you were out for a few weeks and your storage solution dried up. Well, then all those probes have to be replaced. Is the filling solution high enough? So within the probe itself, there's going to be a filling solution, and that filling solution needs to be up to the aeration point. Okay, so that's very important. Have you been calibrating the meter? That is definitely important, as I've said. Do you have an automatic temperature correction probe? Looking at that is really important, because we deal with a lot of different things and turbidities but more importantly, different temperatures with your pH readings, and you want to make sure that your temperature is adjusted for the pH reading. And so there are these little temperature probes that will go in at the same time as you put your pH probe in. And then I talked about buffers. And then this is just a graphical depiction from Hannah and why you might want to do a few things. If you're troubleshooting, you're having some problems with some drifting pH, you definitely want to make sure to make sure that you've got your fill cap open. You want to make sure that fill cap is open on the probe. You also want to make sure that you are rinsing and blotting your pH probe in between measurements. If you're, what Hannah will recommend is not doing any of that. And there are a lot of people that are fine with that you just rinse and then you go to the next measurement. Depends on the sample size, but it should be fine if you just go and rinse and then go right into the next measurement. You could also blot with some Kim wipes. That's how I was taught in school, is to blot. So up to you and what you were taught. We'll talk about acids now. So of course we know about malic and tartaric acid as our major acids. We know tartaric is unique to grapes. And we know that it develops and accumulates in grape tissue early in development of the grapes and then slightly declines due to dilution. One of the things that I can just mention is that there is some release of KHT, so potassium bitartrate, within the berry. And so you will see an increase in pH just based off of the amount of potassium that is pumped into the fruit. You also see some tartaric acid as a secondary metabolite from ascorbic acid derived from sugar development. And then you also see malic acid in the fruit. Malic acid definitely contributes to the overall acidic profile, so important in pH readings. Not necessarily in TA, which we're looking specifically at tartaric acid, but with when you're analyzing your malic acid, which would be a recommended practice when you are looking at your juice. So looking at your initial malic acid contents would be recommended. So sending that out, because what you can do is you can look at your malic acid in juice, then you can look at your malic acid after fermentation and see what has happened. If you've had any sort of wild malolactic conversion, if it happened at the beginning, prior to fermentation, maybe you left your grapes out for a longer period of time and some fun malolactic bacteria got in and just started to go to town, then you'll know for sure. And then you also know your starting point for mallow conversion. So that's something that I think about. Yeah, and so there's some other acids in there that contribute to VA, like succinic acid or butyric acid. Lactic acid is definitely going to be produced through mallow conversion, and so acetic acid as well. And all wine has a bit of acetic acid because it's produced by yeast, it's produced by bacteria, and it's okay to have just a little bit. We know that. So within tartaric acid theory, you see a bunch of different components to tartaric acid. Tartaric acid is pH, is basically based off of pH. It exists in what we call a pH-dependent equilibrium. So there are a number of different components to tartaric acid. And so the theory is that you have H2T, you have partially disassociated, which you can see here. You've got that partially disassociated Cu group on the top. You have a completely disassociated version. And then you also can see here that from the HT, where you've got that negative charge, you can have potassium come in and create KHT. And the potential for a juice to hold KHT is very high. So you can definitely saturate to a higher level KHT within a juice medium versus a wine medium, because in a wine medium you have alcohol, and alcohol then really lowers the propensity for that medium to hold KHT. So you see a lot more precipitation in wine than you would do in juice, but you can see if you're adding acid, you can see some precipitation. So typically what we see in this pH-dependent equilibrium is tartaric acid, hydrogen bitartrate, and tartrate. And all of this is dependent upon pH. And if you bring your fruit in at a high pH, you'll see that it has high amounts of bitartrate. It also probably will have high amounts of potassium. And that's just on the East Coast. We have a lot of potassium if you've got stress that's going on in the vineyard. Sarah and I have looked at this. If we've got some sort of stress in the vineyard like shading, or if you've got some water stress like we had last year, we typically will see a little bit more potassium pumped into the fruit. And thus, if you've got more potassium, you'll have higher pHs generally. So higher pH typically is a result of this pumping of potassium that then combines with, as you can see, this bitartrate up here, which is the more predominant form of tartaric acid at that particular pH. We max out at about 3.65, 3.7 in this relationship. And so a higher pH wine will precipitate more KHT, so you're losing tartaric acid and you're even further increasing pH. So we definitely don't want to do that. So we could call like our acid addition like a sacrificial acid addition, though it does change pH to a greater degree. So when we're measuring acidity, of course, we're evaluating pH, we're evaluating titratable acidity, which is looking at the titratable acids, so specifically tartaric acid. L-malic acid is a different measurement that would be done enzymatically. So if you have a spectrophotometer, then that's something that you can do, but you can always send that out. And then potassium is something different, and you can evaluate that using pH and a conductivity probe if you'd like. You don't have to actually send that out for potassium analysis, but can be helpful, but you can definitely look at it from a pH standpoint. And typically when we're really concerned about potassium is on the crush pad. And we're concerned about potassium because we don't want our fruit pH or our must pH to continue to go up, 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 right? So if we're just seeing, hard pressing, we're extracting a lot of potassium, we're gonna see that decrease in acid, and we're gonna see that increase. So decrease in TA, increase in pH. So what we see in North Carolina can be all over the board. And I wrote my lowest TA to my highest TA. And actually, that's not even my highest TA. I think I saw 14 gram per liter in Petit Mensing that I harvested for sparkling wine. So that's high, that I did have to add some calcium carbonate for that because the pH was like 2.7. So just be aware when you're making sparkling that you've got some different considerations that you'll have to think about. With high pH winemaking, which is typically what we see in North Carolina, though last year we did see some better pHs, is that you'll need to adjust acid. And so I'm a big fan of adjusting acid early. I'm a big fan of adjusting it with large acid additions because we do see precipitation. So a lot of that acid that you add won't actually stay. So if you're adding 5 grams per liter, we're going to see a lot of precipitation. We're going to see a big acid drop. And I would always recommend to do a lab trial to see where that precipitation occurs. And to also make sure that you're actually getting the correct amount of pH drop that you're looking for. Typically, we'll see 1 gram per liter of tartaric acid, lower the pH about 0.1 units. So I would definitely say do that in the lab to ensure that you have some precipitation. Now, this potassium acts as what we would call a buffer to pH change. And so you may not see a direct drop in pH units if you're adding just that 1 gram per liter. Now, we see that a lot in wine because there are other buffers that are a little bit stronger, but potassium is quite strong in juice. And so that's where we see some buffer interaction where we don't actually get a true 1 to 0.1. And so once all that potassium is gone and you've effectively precipitated that, so determine what level you precipitate that acid to, then you can go beyond that and you're going to see big drops because there's no buffers in the solution anymore. Well, there are some, but the major buffer of being potassium, all of that is gone because you've precipitated that out. So
David,
yes.
excuse me, we have a couple of questions. Can you see them?
Yes. So Shruti says, is the pH meter filling solution electrode storage solution the same? No. They're going to be different. So there's a filling solution and electrode solution. And then adjust before or during primary. So you're adjusting your acid before primary fermentation. You would do this in the juice phase. And you would do this on whites and you would do this on rosés. You do this on red wines. Typically we see higher pHs in reds because we're pressing harder and we're macerating. So we extract more potassium. Typically what I shoot for is about a 3.5 pH for reds and around a 3.3 to 3.2 for whites because, but that is really variable based off of wine style. So I put that on there and I always do that with hesitation because there are so many other factors that go into adjustment because we have to account for pressing. We have to account for pressing differences. And of course, after we press, we can evaluate the pH and make your adjustment after pressing. That's probably going to be the best thing to do. Don't want to adjust it before pressing, obviously. So that's good. And then we also have to consider malactic conversion. We have to consider dilution during fermentation, which increases pH. We have to consider KHT precipitation that occurs during fermentation, which happens a lot. So you will see an increase in pH during firm. You'll see an increase in pH during pressing. You'll see an increase in pH during malactic conversion. So all of those things get you to an end result. Hopefully, you don't go above 3.7. If you're above 3.7, then you lose all effectivity of molecular SO2. So if you're adding high amounts of molecular SO2 or SO2 in general above 3.7, then there's no real reason to except for a small amount of, well, there is a large amount of bisulfate because SO2 exists in that pH-dependent equilibrium, and most of it is actually in bisulfate, which is only going to give you oxidation protection, but no micro protection above 3.7. So you just have to consider all of these different things.
All right. I just want to add to the pH solution that you never store your pH electrode in like deionized water or something. So if you really do not have any storage solution there, you can either make it, it's usually a 4 molar potassium chloride solution.
Yes.
And if you do not have any storage solution and you need to store it for like a day or so, you can do that in a pH 4 or 7 buffer, but don't do that for too long. But never in water. That just, yeah, I just wanted to add that. Yeah.
Thanks.
All right.
Hey,
Okay.
David.
Yeah.
Can you just, because I see it a lot when I'm traveling around, or last year I did. What happens to your pH probe when you don't store it in anything? You just leave it on the counter dry?
Well, it definitely will dry out, and so that moisture is needed in order for it to leak. And so if you are if you're not storing it and keeping it hydrated, you'll see drifting, you'll see slow response times, incorrect measurements. And so that is the problem. So you're getting that drying on that, and it's a semi-permeable glass there, and so you can have some clouding and problems. And then what Hannah recommends here is that you can start to revive it after a certain period, but in my experience, that does not work very well.
Yeah, no, in my experience also, no.
Yeah.
So, David, I give you another 2 minutes, but we're running way over time. So, that's okay with you.
Yeah, I mean, I'm almost there. I just have a few more slides.
Right.
So this is the protocol for acid trials. If you want to take a screenshot of that, it requires a micropipetter. So you have to make a standard solution of tartaric acid, and then use a micropipetter to add that. And then you can add that standard while you're recording the pH on the in the juice sample, and look for precipitation to eat through your buffer. And that will help you better understand your ending pH, or excuse me, your starting pH, and then you can evaluate what your ending pH will be after that. If you're with white wines, remember that you will go through cold stabilization, which will reduce tartaric acid and increase pH if you are below 3.7. So keep that in mind as well, okay? And then briefly about sugars and using the refractometer, that is not a difficult point. Sugars, principal grape compound, what we want to ensure that we have enough sugar to go through fermentation, and we also want to make sure that if we don't want to have too much sugar can put undue stress on the yeast cell membrane, cause stress, and then also we have alcohol that's going to limit production at above 7% in your wine. So you're going to create some stress factors for the yeast if you're above 7%, which of course we all are. So yeast are picking the right yeast for you is important. You know, you don't want to. There was a yeast that I used years ago, DGI 228, which is the Steinberger. The Steinberger is awesome for what it is, but it doesn't have a whole lot of alcohol tolerance. I think it ends up at around 12%, which, you know, is maybe 11%. So what I find whenever I use that was a yeast that I could use to keep residual sugar in the wine, and that's exactly what it did, and it was actually quite nice. So sugar, kind of fun. Make sure that you calibrate your refractometer before you use it. This is pretty simple. You use DI water and put that over your prism on your refractometer face. You want to make sure that I can annotate this here, I think. You want to make sure that your field of view is at 0 when you're using the water. Make sure that you're using a Kim wipe to completely dry this prism face before you add your 3 to 4 drops of juice sample. Remember, this is measuring soluble solids, so you may have some problem might be a little bit off just because there are other soluble solids that might refract in light. So you might see a little bit of a change. That's why using a glue-free measurement is what I would recommend. And then beyond that, using a densiometer, which would give you an even better measurement. Make sure that you calibrate before. You can use your little calibration tool and just twist the refractometer to get this field at 0. Then chaptalization, we know that we're chaptalizing to make more of a balanced wine. And it's also determined upon wine style. Chaptalization and sparkling obviously would not be recommended. So you might see this year is what, I mean, I give you this option or this example. This is probably what you'll see in your Cabernet Franc maybe. And so that is a low Brix, that is a high pH, that is a low TA, and it is a low Yan. So I would say that to make a more balanced wine, we see a conversion rate of 1 brick to 0.55 to 0.59. Now, Scott Labs, Megan, Michael, you probably could argue with me that you might get better conversion, but you know, in a typical fermentation, we may see that range of conversion. Maybe in some of your more higher powered yeast, you might see 0.62 conversion, but I always calculate potential alcohol in a range. So if I'm at 22 bricks, my potential range of conversion would be between 12.1% and 12.76%. That would be what I would evaluate in terms of looking at my potential alcohol and what I would want to do to increase my bricks during chaptalization. So as you saw with my acid add, I do calculate everything in liters. And remember that 1 brick or 1% sugar is equal to 10 grams per liter. So if we're increasing by 20 grams, we can calculate that. Remember 454 grams per pound, and we can get it back into pounds. We also need to make sure that on our 51-2017, when we are notating that we did add sugar, for any sort of measurement, there is a volume increase. So if you're adding this to wine, this is where you would add that on 51-2017, but you also need to know your gallonage increase for calculations for like your yeast and for your yeast nutrient additions and things like that. And so you can calculate your increase in poundage by using the calculation of 1.7 kilograms per liter. Okay. And then if you don't have any questions, that's it. Happy harvest. And if you do have any issues, give me a ring or give Megan a ring.
All right. Thanks, David.
Thank you all.
Yeah,
thank you all very much.
Thanks for having us.
Yeah, thank you for sticking around so long. We went way over time. I think we had a good conversation. Thank you very much. To California especially. I see the sun is up now.
No, it isn't.
It's not.
We're fogged in.
All right. So where are you at? Are you at the Central Bay?
Where am I at?
Yeah.
I'm in Napa.
Oh, okay.
But actually I live right on the Napa River, and we're still fogged in. It's a high fog, but it's a little bit chilly out there.
All right. Well, thank you very much, everybody. I appreciate it. And
thank you, Mark.
Thank you for sticking around. Everything will be available online by tomorrow on our Grape portal as well.
Thank you so much.
Yeah. Thank you,
Mark. Thank you, Patty.
Have a good day.
Thank you, everybody.
Bye.
Bye.
Bye-bye. Bye, David.